Let us talk about introduction to design and analysis of algorithms in this video. So, what is an algorithm? An algorithm is nothing but it's a structured sequence of instructions or an operations to solve a problem. So, solving a problem usually involves computational tasks. So, when we are talking about algorithms, here we are very specifically talking about tasks which can be solved by computational operations and by executing computational set of instructions. So generally we write an algorithm to solve a problem, and that was specifically of a computational nature. And most often these computational tasks has to process an input and generate an output. An example could be like calculating a factorial of a number, wherein the number would be acting as an input and the calculated factorial value would be acting as an output. So often algorithms are translated into computer programming languages for execution on computers. So given this understanding of algorithm, let us see how to represent an algorithm. Generally, algorithms are represented in two ways. The first is by using a flowchart, which is nothing but it's a diagrammatic representation using various symbols and shapes. And we usually use flowcharts to depict algorithms of trivial nature, which are smaller and which work for a smaller problems. For larger problems, we move to the second method to represent an algorithm, which is by using a pseudocode. And when I say pseudocode, I mean English language like sequence of unambiguous instructions. So it is like a set of small instructions where each instruction is written in English language like sentence. And the peculiar property of a pseudocode is that each instruction in pseudocode is unambiguous. The instruction in pseudocode doesn't mean two actions to be done or some kind of ambiguous decision making. No such type of fancy stuff here. Pseudocode is English language like a sequence of unambiguous instruction. So given that we know how to represent an algorithm, let us study why to design and analysis of algorithms. I mean, why to study design and analysis of algorithms? What is there? Why to study a whole sort of algorithm design techniques, analysis techniques? So to get a clear, convincing answer for this, let us think of a small problem. So let us think a situation where you have to buy a new t-shirt and a pair of shoes for your first day of your college, but you cannot ride a bike. But you do have a bike and you have two friends of yours, namely Alex and Bob, who follow your instructions. But the condition is that only Alex knows where to buy a t-shirt and only Bob knows where to buy a pair of shoes. And when these friends want to buy a t-shirt and a pair of shoes, they have to buy it from a shops, and all these shops are lined in a series in a specific straight line. And it is a fact that shop 2 sells t-shirt and shop 5 sells shoes. So we could visualize the scenario as we see here in form of diagram. So shop 1, shop 2, so on to shop 7, and that's how the road follows, and there is a dead end of that road. So another condition is that either Alex or a Bob would be driving the bike at a time, and when one is driving, he cannot watch out for the shop. Only the person who's sitting behind the driver on the bike can watch out for the shop which he knows what to buy from that shop. So given this scenario, if I ask you to form a set of instructions which would lead to a situation where you will be having a new t-shirt and a pair of shoes bought by Alex and Bob for you. So one of the approach could be approach A, let us call it as approach A, where Alex would drive the bike and Bob sits behind. And while Alex drives from shop 1, Bob watches out for a shop where he can buy shoes. So Alex would start at shop 1, he will move to shop 2, shop 3, shop 5. Meanwhile, Bob is looking for a shop which he knows that he sells the shoes. So he would ignore shop 1, shop 2, shop 3, shop 4. And the moment Alex reaches to shop 5, Bob asks Alex to stop at shop 5 and buys the shoes. And once Bob buys the shoes, they have not yet bought T-shirt. So now Bob drives and Alex sits behind on his bike. And Bob now further drives to shop 6 and shop 7 till he reaches the dead end of the road. So when Bob reaches to the dead end of the road, he obviously takes a U-turn and drives to the origin. And in this process of reaching to the origin, Alex keeps in watch from shop 7, shop 6, 5, so on till he reaches shop 2 via their journey towards origin. And the moment they reach to shop 2, Alex asks Bob to stop at shop 2 and buys a t-shirt. And Bob drives to the origin and you end up with having a t-shirt and a pair of shoes. This is approach A. Let us also think of approach B. Here, Bob drives the bike and Alex sits behind at the start of the process, at the start of your journey. While Bob drives, Alex watches out for a shop where he can buy a t-shirt. So when Bob was driving from shop 1, shop 2, suddenly Alex finds that he knows the shops too where he can buy the t-shirt. So Alex asks Bob to stop at shop 2, buys t-shirt. And now Alex drives and Bob sits behind and they proceed their journey toward the dead end of the lane to scan all the shops. So Bob asks Alex to stop at shop 5 and buy the shoes. At this point, both Bob and Alex are done with purchasing t-shirt and shoes. So now Alex takes a U-turn right at the shop 5 and he drives to origin and you end up with having a t-shirt and a pair of shoes. So both approach lead to the solution, but one approach here is better than other one. If you think here, approach B is better than approach A because in approach B you end up saving a fuel which you avoid by taking U-turn at shop 5. So you unnecessarily do not visit shop 6 and 7. So the whole point of discussing is that a problem could have multiple algorithms leading to a solution. So in this case, not all algorithms for a specific problem could be same in terms of various factors, especially time or steps required to generate a solution. So in our problem which we were discussing, the fuel efficiency or the amount of fuel spent in realizing and in buying t-shirt and shoes could be one of the factors which could lead to an optimization problem. So a comparative analysis of various algorithms could tell us which among the various algorithms is best for generating a solution to a problem. That's why we analyze an algorithm. And when we say we analyze an algorithm, we analyze algorithm for its efficiency in terms of time taken to generate the solution or other factors. For example, it could be space occupied by algorithm to generate the solution, various other factors. So that's why we analyze in algorithms, because multiple algorithms could lead to a solution and we are always in a search for a good algorithm which gives us better results in a quick amount of time, requiring less cost. So cost could mean various other factors as well. It could be space, I said, it could be memory requirement, it could be number of I/O access, it could be any other number of file read operations in our general computer terms. So when we are talking about analysis, why should we also study design of algorithms? So if you look at earlier two approaches, we can make a comment that appropriate and well thought method of designing algorithm could lead to better algorithm as compared to analyzing all possible algorithms and choosing best among them. So by following a proper design method to design an algorithm, you can always make sure that you generate a better performing algorithm which performs far better than alternate algorithm to generate a solution for a specific problem. So there are various approach to analyze and design algorithms, and that would be the further study of the concept which we will be looking at in the further coming sequence of videos. So I hope you got a fair bit of an idea what exactly is analysis of algorithms and design of algorithms and why we study them. So that's it for this video. Thank you.